In order to answer parts A and B of this question, we'll have to extract some properties from the function given. In order to get those properties, it might be helpful to reference a formula. So let's take a look at the formula for a cosine function. That is a cosine of b times x minus c plus d. Recall that the a is the amplitude, so amplitude is A. There are some other properties such as phase shift. Phase shift, which is just C. There's a midline, which is a line of y equals d. And the complex one here, a little bit weird, is that the period is 2 pi over b. All right, for parts A, notice that it's asking for the period, so we'll need to know this 2 pi over b part. So first of all, we have to identify the parts of this trig function right here. Well, you can see pretty obviously the number being multiplied to your cosine is your a, so a equals 5. Furthermore, the number being multiplied to your variable, in this case x, in this case t, here is pi over 20. So that means b equals pi over 20. 20. No number is being added or subtracted inside the cosine function, so there is no c, and d is 0 because there's no number being added or subtracted outside. So the d is equal to 0 and c is equal to 0. Alright, if 2 pi over b is the formula for period, and b is pi over 20, then 2 pi over 20 is the period. However, I might want to simplify this a little bit, so I'm going to multiply by the fraction instead of dividing by it. Specifically, it's reciprocal. We can cancel out the pi's here, and we can see that the period is 40. That answers the first part of part A. It asks determine the period, but it also asks for the frequency of the wave. The relationship between frequency and period is a really simple one. Period and frequency are reciprocals of one another. So in other words, frequency, if period we call p, so p equals, then frequency is just, if we call frequency f, then f is equal to 1 over p. Here, since p is 40, then this is 1 over 40. As for units, since t is measured in seconds, period is in seconds, and frequency is 1/40th of a wave per second. Alright, but we also have part B here. It asks the wave height, that is the vertical distance between the wave's trough and crest. So first of all, let's draw a little sketch of our graph here, just as an example. I'm not too concerned with getting the period right. The main thing I'm concerned with is making sure a cosine fits. And a cosine function looks something like this. Note that the distance from the midline, which here is 0, to the top of a wave, and from the midline to the bottom of a wave, is just the amplitude, which we already found is 5. That means that the distance from the trough all the way to the top of the crest is 2 times a. So in other words, 10. The original units are measured in feet, so this is 10 feet.